Well, hello, ladies and gents. Here we are in the last section, skin appendages. It's all the stuff you find in the skin. So that includes cutaneous glands. They're exocrine glands. That means they have a duct and it leads to a surface, in this case, the surface of the skin. And those include basically oil and then watery sweat glands. And then we have hair and nails. All right. So let's start by looking at glands. Sorry, I've got a sneeze coming on. Okay, so one type of gland is an oil gland. It's called a sebaceous gland. Sebaceous glands produce sebum. Sebum is the oil that's in our skin and hair. So if you've ever had oil on your skin, like I do here, or oil in your hair, that is sebum. Now, why would our body produce that? Well, remember, your skin is dry, so you don't want your skin to crack, and then if it cracks, it'll allow pathogens in. So sebum is an oil that helps lubricate the skin and the hair, so it's less likely to crack or fray. Okay, sebum also is antimicrobial. It'll have proteins in it, and it's somewhat acidic, so that helps keep bacterial growth down. Okay, let's see. So again, that's the big idea there. Sebum, it's the oil on your skin and on your hair. And again, its job is to help lubricate the skin and hair and prevent it from becoming brittle. Here, you see sebaceous glands. They're associated with follicles. So here you see a hair follicle. The sebaceous gland is sort of that mushy thing associated with the follicle. And then the sebum will travel up through this duct and onto the surface of the skin and again, lubricating the hair. All right, we also have sweat glands. Now, sweat glands will produce a couple different types of sweat. Here, I like this image because here you see the sebaceous gland that produces the oil, and then here you see this watery sweat gland, and it's a different gland, has its own duct, travels to the surface of the skin. And we'll have sweat glands all over the body. Now, sweat glands come in two different types. There are eccrine glands and apocrine glands. Eccrine glands, those are the sweat glands that produce this watery sweat that we find all over the body. Our eccrine glands produce this watery sweat that cools us off. Apocrine glands are slightly different. These are sweat glands that are found in the armpits and in the groin. They become active at puberty, and they produce what's referred to as a milky sweat. This is a different type of sweat that has a lot of like metabolic waste from the body. And since apocrine glands produce sweat in the armpits and groin, those parts of the body, think of like your armpit, it doesn't release that moisture as readily. And because it's rich in nutrients from these metabolic wastes, it can promote bacterial growth. So that's why people get like stinky armpits, right? Part of what makes armpits stinky is this apocrine sweat that's produced, coupled with the moisture that's retained by the crease of the armpit. It allows bacteria to grow. Here is just a cutaway looking at the gland. So there you can see the epithelial tissue. You have like the simple cuboidal epithelial tissue produce that watery sweat that can travel to the surface of the body. All right, so what do we find in sweat? Well, again, sweat is mostly water. You will find salts that are in sweat. So sometimes you'll see like salt crusting on their clothing or on a hat. It's because of the sweat or the salts that are released through the sweat. Metabolic waste, again, like urea or uric acid, will be released through sweat. And again, in the apocrine glands, you can get these fatty acids and proteins from metabolism, and that can be food for bacteria, like in the armpits. Now, why do we sweat? Well, again, you can get rid of waste products. Okay, so if you have a bunch of metabolic waste in your blood, some of that can be actually excreted through your sweat. When watery sweat from eccrine glands evaporates off the skin, that draws heat away from the body, so that can cool you off. And then again, sweat also has antimicrobial properties, so it can help impair bacterial growth. Now, again, people get stinky armpits and stuff like that because of the metabolites in their sweat and the fact that they're trapping that moisture. So that's why people may use like antiperspirants that sort of block the release of the apocrine sweat. One thing I want to mention, though, sometimes people confuse sebaceous glands with sweat glands. Sebum is oily, so it sort of lubricates the skin and hair. That oil doesn't evaporate readily, so it's not going to cool you off. Sebum doesn't cool you off. Eccrine gland sweat. Sorry. Someone's walking a dog. Hey, Alice? Alice, you're all right, man. Someone's walking a dog by our house, so now my dogs are freaked out. So again, I apologize for that. All right. It's okay. So whatever we were talking about, sebaceous glands produce oily sebum. That's not going to cool you off. Eccrine glands produce watery sweat, and that will cool you off. So don't get tripped up on that. All right. So what else do we find in the skin? We find hair. Hair will be produced down in this bulb by hair follicle. It's a connective tissue that sort of surrounds the growing hair, and then it has an epithelial tissue that produces the keratinized cells. Now, hair is keratinized, so the keratin in your hair is similar to the keratin that's in your skin. And of course, there are melanocytes that can provide pigment. So our hair is pigmented because of melanocytes. So you can see how hair is related to your skin. So this sort of zooms in. Again, here you see the follicle surrounding tissue. You'll have the connective tissue that holds it in place, and then this epidermal tissue where new cells are being produced. Here are the melanocytes producing that melanin. So it's really cool that hair is sort of a way to look at how skin can evolve, right? Or the tissue that is skin can evolve. Now, what's the value of having hair on your head? Well, hair is not living, right? And because it's not living, it's not going to be damaged in the same way that living tissue would from UV radiation. So when the sun is up in the air, you can have UV radiation striking your head, but if it's covered in hair like that, the hair can actually absorb that UV radiation and protect you from the sun. Of course, I've reached a point in my life where I need to wear a hat during the summer because of the UV radiation, but hair, does provide those advantages. Okay, what else do we find associated with the hair? Well, you'll have the hair follicle, which is that tissue down in the bulb there. There's what's called an erector pili muscle. The erector pili muscle attaches to the shaft, or I'm sorry, the bulb surrounding the hair and your skin. So that's a smooth muscle. You don't have conscious control over it. And when it contracts, it pulls your hair so it stands up. The idea behind that is it's what's called a vestigial response. It used to be back when our ancestors had more hair around their bodies. You could have the erector pili muscles contract and it lofts the hair. If you loft the hair, it traps air, and then still air acts as an insulator. Not a lot of people have down jackets anymore, but maybe they have a down comforter or down blanket. Down is a type of poofy feather that you get from waterfowl, like ducks, okay, and or geese, I should say. So if you take these lofted feathers and you stuff it in something, it is really poofy, so that traps air, and that still air acts as an insulator. So again, some animals can loft their feathers or have their hair stand up, and it traps heat. Now for us, we don't have that much hair around the surface of our body, so it doesn't really trap heat. It's what's called a vestigial response. It's something our bodies still do, but it doesn't really work in the same way as it did for our ancestors because we just don't have that much body hair. Now, sometimes it does tie to our nervous system, so if a person's scared, you can have goosebumps. Now, the goosebumps aren't really rising things up. What happens is this muscle pulls down on the skin, so the hair will stand up, and the skin gets pulled down, so it looks like you get a bump. So it's really just pulling down on that skin tissue. Okay, and of course we have sebaceous glands associated with hairs because that oily sebum travels up and out. All right, so here we can sort of zoom in. Looking at a hair, you can see how it looks sort of scaly with those cells. And again, they get filled with keratin, and then those cells will die. So, hair is non-living tissue that's created by those epidermal cells. Now, our nails are also filled with keratin. So you can see how valuable keratin is. It makes our skin tough and waterproof. We use it to make hair, and we use it to make nails. You even find keratin in like horns in animals. Like a horn on a rhinoceros is made of keratin, which is sort of crazy because sometimes rhinoceroses have been killed for their horns because they're thought to have like medicinal qualities. But it's really, I mean, it's the same proteins as you get in hair and fingernails. So I don't know what sort of medicinal value that a rhinoceros horn might have that would be different necessarily than, hair or fingernails. But anyway, nails, again, they're this modified keratinized tissue. Now, do our nails have melanocytes? And if they did, our fingernails would be brown, right? So they are colorless because they lack those pigment producing cells. All right. In terms of the structures of a nail, the free edge, that's the end of the nail that gets cut or trimmed. The body, that's the part that you paint, right? And then the root is embedded in a fold underneath the skin. Okay. And the cuticle is the part, is a little extension of the tissue that can get pushed back. Now, why have nails? What's the value of nails? Well, the last digit, called a phalange, the last digit in our fingers and toes are really pretty narrow. They're sort of triangular shaped. So by having a broad, flat nail, it gives us better ability to grasp rather than having like mushy fingers. If we didn't have those nails, we'd have fairly mushy ends to our fingers, and it wouldn't provide the same sort of support that a nail does. It also protects those bones. So it's helpful to have a nail. So there you see, again, you see that free edge. It's the part that gets trimmed. The body is the part that can be painted. And then the root is down here. It's underneath this fold at the end of the nail. And the matrix is where the keratinized tissue gets produced. So it gets pushed out. If anyone's ever smashed a finger, you can actually crack the nail. And then as more keratinized tissue gets produced and gets pushed out, then that crack of the nail will actually cause the nail to fall off at a later point in time. All right. And here, there's sort of a nice image of the last little bone in your finger. You can see how that narrows. So it's helpful to have that broader pad to help protect the bone and give you a firmer grip. All right. That is that. Congratulations for making it to the end. If you have any questions, let me know. Otherwise, have a great